Hello and welcome, 7th graders. If my voice sounds funny, it's because my children are asleep and I need to be a little quiet. Hope you guys are doing well. Sorry I can't be there. Here we go. Let's talk volume and surface area. At the same daycare, Kieran sees children climbing on this foam play structure. I'm not really sure what the same daycare is. It says Kieran is thinking about building a structure like this for his younger cousins to play on. The entire structure is made out of soft foam so the children don't hurt themselves. How much foam would Kieran need to build this play structure? Okay. So I didn't draw this. I traced it. And that's a strategy you might, if you want to redraw this thing, just get a separate piece of paper, lay it on top, and trace it, obviously, but see what we can come up with here for an answer. So the amount of foam that makes up this structure, obviously, is the volume. It's the amount of space this thing takes up. It's the amount of stuff you need to fill that specific space. And so clearly, we've got a couple of options here. I'm going to start cutting this thing up into pieces that I can deal with. And so the first one I'm going to do is I'm just going to cut straight down there like that. And I'm going to think of this, I should have highlighters. I'm going to think of this as like a rectangular prism all by itself. This one piece that's 8 inches across and 5 inches down. If I redraw this thing, it's not perfect, obviously. But I cut off that piece. Oh, sorry, you can't see that. I cut off that piece. It's 5 inches tall, it's 8 inches across, and the whole thing looks like it's 20 inches. If you're not really sure of those measurements, I had a 6th grader come up with something kind of clever, which was you highlight the 20, and then anything that's parallel with that 20 also gets the same color, and so then anything that's red must be 20 inches long. So I thought that was interesting. So yeah, this thing is 20 inches long. So the volume here is big B times H. Big B, I'm going to say, is 5 times 8, which is 40. So 40 times 20 inches deep, it's an 8 with 2 zeros, is 800 cubic inches of foam just needed for that one piece here. Okay, the next piece I'm going to look at, you can pause the video now and make sure everybody agrees where that number came from. Okay, let me look for a highlighter real quick here. Okay, never mind. So I've got a blue pen. Next thing I'm going to do is cut here. Come on. There we go. Right, and so now there's this rectangular prism. Something like that. That's, if I outline it like that, right, so I'm cut that into a middle rectangular prism. I'm going to redraw that thing. So it's taller than the other that I drew before. And this distance across the top is 10 inches. Now, this is 5. It's not 5 from the corner here all the way down. That's not the height. So if I use that sixth grader strategy where this is 5 and anything across from it, that's that same distance, that is also 5. I guess it's not perfect alignment with that sixth grader strategy, but whatever. So this is 5 because that same distance, that's 5, so this is 5. But then they're also saying that this is 5. So from, I don't know if you want to call it like point A to point B. I don't know, from here to here, that's 10. So that's 10 inches. So that's a square then. And again, it's 20 inches deep, right? It's got a width of 20 inches. Okay. So volume is equal to big B times H. Big B is the area of this face, which is 10 times 10, which is 100. So volume is equal to 100 square inches times a depth of 20. 20 times 1 is 20. And then add these 2 zeros is 2,000 cubic inches to go inside this middle piece. If we call this, I don't know, we'll call this, well, I've already used point A and B. I'll get rid of those. We'll call this piece A. We'll call this piece B. So here's A and here's B. I think I'm going to cut this into 4 shapes. And there are probably people in this room who've treated this like a trapezoid on its side, right? So B1 would be that little 2-inch section, and B2 would be this, which I think is 10 inches. You can do that for sure. It'll save you some time. But I think instead what I'm going to do is cut this remaining piece into 2 pieces. And I'm going to do that by creating a thin, like, pizza box. It's this distance across, and it's 20 inches deep, and it's only 2 inches tall. Let me see if I can draw that. I guess that's supposed to go there. Oh, nuts, I drew it wrong. Anyway, okay. Okay, so now that piece, if I take that out and slide it down here, okay, 2 inches tall. Okay, so it's 2 inches tall, 20 inches deep. But what is that distance across the bottom? How can we get that? Oh, okay, it's going to be subtraction, excuse me. It's going to be subtraction because the whole thing is 36 all the way across the bottom. Okay. Box A is 8 inches across its bottom. Box B, let's say, it is. It can't even let's say, it actually is 10 inches across that bottom. So I'll pause for a second. Tell your partner how wide this leftover piece is. Okay, so what you should have said was 10 plus 8 is 18. Take that away from the 36, which is the entire distance across. I think it's 18. Let me just check that real quick. 18 plus 10 is 28 plus 8. Yeah, it's 36. So this thing is 18 inches across, this pizza box looking thing. So volume is equal to big B times H, big B. I'm going to do 18 times 2 to get this face, and then multiply by the number of layers that way. So that's 18 times 2, which is 36. So volume is equal to 36 times 20. 36 times 2, 72. Add a 0 onto the end because it's 20 after all. So the volume there is 720 cubic inches. We're getting there. So that's C right there. Rectangular prism A, rectangular prism B, rectangular prism C. Here we are. Prism D, which of course is not a rectangle. It is a triangular prism. Okay, so across this bottom is the same distance across the bottom of C, so that's 18. I've got a right angle here, which is going to be useful. And then the height. The height of this triangle. Pause for a second and see if you and your partner can figure out just the height of the triangle, not that little bit right there, just that height of the triangle. Go. Okay, so what you should have said was, we decided that B was 10 inches from top to bottom. Well then, this whole distance is 10. That little guy is 2, so the height of the triangle must be 8. So that's 8 there. Okay, so again, it's 20 inches deep across this shape. And so here, let's do this up here. Volume is equal to big B times H. Big B is the triangle now, right? Because the triangle, yeah, that's definitely not 18 inches, but we'll pretend that it is, and 8 inches tall. What that means is you can fit, well, 1/2 18 times 8 cubic, what is it, inches, cubic inches inside of that one layer, and then you have to multiply by 20 layers because it's the triangle that repeats all the way through this shape. You know, if you draw the 3D version of it, there's the other triangle on the other side. So 1/2 of 18 times 8. I know that half of 18 is 9. 9 times 8 is 72. So big B is 72. So volume is equal to 72 square inches times the height. The height is 20 inches from front to back. 72 times 20. Automatic 0. 2 times 2 is 4. 2 times 7 is 14. So it should be 1,440 cubic inches. And that is just for shape D, right? Yikes. So now we've got all these things that we need to add up. Shape D, let's just start there. 1440. Shape C, we said was 720. For 2,160. Shape B is 2,000 cubic inches. So now we're at 4,160. And then shape A is 800 cubic inches. Add that on, and you get 4,960 cubic inches. And that is your answer for part A of this massive open response problem. If you got that, give yourself a nice little pat on the back. That is a decent question. There's a lot to that. And if you get that, then you have a good understanding of how this material works. All right, that's part A.